Alright, so in this video, I'm going to do a comparison from this coil, a coil that's going to be charging this capacitor bank, and then this stepper motor is going to be charging this capacitor bank. The large one is on the coil in here for that capacitor bank. That's the large multimeter, that's this one. And then the one on the right here is this meter. And I shorted both of them to try and get them like close as I can, but you can see that they're kind of floating back up now that since I charged them. But I just want to show the difference between the two. So I'm going to power it on. Alright. So I'm charging with this and the coil here. So the stepper motor right off the bat has a higher output at this lower RPM, but the voltage is lower. I think I can only get the capacitor bank to like 3.2, 3.3, and I'm fully rectifying the stepper motor completely, and then I'm just jumping the two together to get the series output. So it's fully rectified, and the output is still climbing pretty decently. This is the stepper motor, and that's the coil inside the motor here. But I did notice as this one got to a higher voltage, around like 1.5, 2 volts, this one started to outperform the stepper motor because of the difference in voltage. This output like 22 volts on the output, so there's a big difference in voltage, which is helping the higher output as the voltage gets higher. So this one has more current at the down low, the stepper motor, because of obviously the bigger coils in here. I'm sure they're a lot thicker than that. But there's a disadvantage when it gets to the voltage range to where it can't charge as much. The output gets lower. And then as this one gets more to the higher end of 3 volts, it will pretty much drop way down to where it's barely charging, and then this one will start to pick up and it'll start outperforming that one because of the difference in voltage, I believe. Current's lower, but the voltage is higher, so it's able to push this one more than that one. Now we're going to start getting to the point where we're going to see this one jump up faster than this one, because the voltage is leveling off versus this one has a long ways to go. Yeah, you can see this one is starting to taper down comparing to the rate of charge on that. Like, look at that. That one's really starting to outperform that one now by a pretty large amount. I hope this doesn't take too long to record this, but I kind of want to show you guys how much the difference is. Because I know the stepper motor, for one, takes a lot of drag just to get it to turn. And this really doesn't have much drag other than the fact that, you know, it's whatever the output is what it is, because there's no really friction other than the electromagnetic generation going to the capacitor, as where the stepper motor has a lot of drag on it just to turn it without no power, without generating anything. It's it just there's a lot of drag. And then this smaller stepper motor here it does turn easier, but it's still there's a lot of drag comparing to just having a coil in the motor itself. I'm sure if this had thinner wire where the voltage could even be higher than what it is currently, it would help. But it's starting to creep up higher and higher where the regular coil in the motor is outperforming the stepper motor generator, which is kind of underwhelming in my opinion. I was thinking this stepper motor would actually work better than just having a coil in the motor, just because the fact that it's it's an actual motor with iron core and a lot of um, pulses to generate a higher frequency to get a higher voltage output, but doesn't seem to really benefit me that much for generating electricity. I'd be better off just having a bunch of these coils in between, put them all in parallel, or probably put them all in parallel, and probably have a much better outcome than just using a standard motor that comes, off the shelf. I think it's a good idea, but for practicality and trying to make something run as efficient as possible, it's not great for as a generator. Yeah, now we're getting even closer to the threshold where this one's gonna really start overcoming that one. I mean, you can obviously see the rate of charge is a lot higher. I could probably get maybe like I think this is 32 gauge or 30 gauge, one of the two. I could probably step it down to around 26, 24 to get more amperage out, and it'll still have plenty of voltage to charge. Because I really only need like a peak of like 4 volts, but the power difference is quite a bit. So I don't know. I'm still not sure on this stepper motor. Just the fact that it just has so much drag. But yeah, we're getting even closer now to where this one's gonna pass the stepper motor. And this coil is only rectified once. I'm not, going through a bridge rectifier, so it's only using half of the output of that coil. So that's another thing, is if I were to use both sides of the pulse, it'd be generating twice as much. That's another thing I gotta factor. And I'm even fully rectifying the stepper motor through these bridge rectifiers. So the output is pretty weak considering the size of the stepper motor. So I think I'm gonna try doing a full rectification on this coil to see if the output is even more. It should be. It should be double of what it is. Now you can see that it's getting about to the point where it's going to pass the stepper motor. And the drag off of this is nowhere near the amount of drag off of that. And if I were to remove the stepper motor, the motor would increase in RPM, so it would output even more power. And I already have done this actually already before I even got the stepper motor, and it still wasn't enough power to make it run. Alright, so now it has exceeded the stepper motor, and it's about the same amount of rate of charge. So now I'm just going to disconnect this stepper motor charging this capacitor, because obviously we see the output isn't great. So let's do that. Alright, so that's disconnected. Now we'll see this go up even better. Now if I disconnected the stepper motor and pulled it off, this would spin faster because there's a lot of load on this, or there's a lot of just drag on the motor. So that would help it even more. Once it gets to 3 volts, I'll cut this video because it's already over 10 minutes. But yeah, theoretically, this coil could generate enough power to get these to 16 volts, which would be way more than enough than what I would need. But yeah, we're already past 3 volts and climbing. But yep, I'll cut it off at 11 minutes here. See you later.